If you have ever staked, bridged, or swapped any tokens, you must have definitely approved a smart contract to spend your tokens on behalf of you. And this can be a security risk because most of the time, these smart contracts approve more tokens than required for future convenient transfers. So having a feature or an app using which you can check your token allowances for various token smart contracts can be useful. So hi everyone, this is Sahil from QuickNode. Today in this video, we will create a token allowance checker using QuickNode Streams where we will be able to check token allowances for a particular wallet address. So without any ado, let's jump into it. We will be following these steps to create our application, where the first step would be to create a Postgres database instance to store our indexed data. So we will be getting data from QuickNode Streams, which is a powerful solution to get your blockchain data. You do not need to worry about constantly pulling the blockchain. You just set up your stream once and it will keep sending the data to whatever your destination is. The first step is to create a Postgres database. So let's do that. I'm using Tembo as my hosted Postgres database provider. And to create a database, I'll just create a basic Postgres database and deploy it. I will name it instance 2. You can name it anything. And as you can see, it's being provisioned. So it can take some time to provision the database. So without wasting time, let's take a look at the one which is already active and live. So once your database is provisioned and live, you will see a button like this called show connection settings, and over there you will have this connection string over here with all the details like hostname, your password, username, port, etc. etc. This can be used to connect your database to your local machine in terminal. So let's just copy this, go to our terminal and paste it there. Okay, so our database is now connected in our terminal, and the next step here would be to create a stream of logs and filter the data and send it to the newly created database. This step is completed, and now let's go and create our stream. So to create a stream, you just have to log into your QuickNode dashboard, then go to streams and then create a stream. So we will be indexing the Ethereum mainnet logs. So select the chain, Ethereum, then network, mainnet, and then the data set. So what we will need is the logs for token allowances, which are emitted by ERC20 smart contracts. And then the stream name comes here, then the region and batch size. Then you can have a stream start block and end block. In our case, we will be just starting with the latest block because it's just for the demo purpose. But if you were to index the entire chain, you will have to enter the block number. It can be 1, and then you can keep the stream end as doesn't end so that it keeps indexing or it keeps sending the data for every latest block. So for us, let's just select latest block. And then after that, what you can do is you can modify the payload of the stream. So let's look at what the raw payload for logs looks like. So as you can see, we get topics, we get the address of the contract, block hash, block number, the data, log index, transaction hash, transaction index, etc. But we don't need all of the logs. We just need specific token approval logs, which looks like this. Let's go to ERC20 smart contract. And if you go to events, search for a specific event. So we want to just index these approval logs for various ERC20 smart contracts, and the log topic 0 or the event signature for this log is this. So that's what we will be doing. We will be targeting that particular event signature, which is always stored in topic 0. So with streams, what you can do is you can create a filter for your data so that you do not get any unnecessary data and you just get the data which you care about. So let's modify this filter. What we are doing over here is we have 4 functions. We have function extract address, we have hex to decimal, then we have filter logs, which is find and filter logs, and then the main function. So anytime you're creating a filter, you need to have a main function because that's where the logic starts from. So in our main function, we are calling the find and filter logs, which is this function. But let's go function by function. With function extract address, what we are doing is we are taking away the padding around the address, which is present in the event logs, because the actual address is just this much, which is 40 characters. So what we are doing is we are saying that if address or padded address is not of type string and the length is less than 40, send an error. But if that's not the case, slice the ending 40 characters of that string and add a 0x prefix and then return that. Then for the function hex to decimal, what we are saying is that if the data, which is hex value, if that's not a string, throw an error. And then we are removing the 0x prefix, which is there with every data. So we will need this function to convert the amount and the block number into a more tangible format. So we will convert them into integer and then big int so that we can like easily identify the amount and block number. So first we are removing the 0x prefix, and then we are converting the hex to a big int number. And then finally, in find and filter logs, we are targeting this particular event signature and initializing an empty results array, and then initializing a flag signature found as false. And then we have a iterating function called search, where it will go over different logs and find topic 0 for this event signature and then return the data. And then it will extract address for wallet address from topic 1 and extract address for spender address from topic 2. As you can see in the event itself, the topic 0 is the event signature, topic 1 is the owner address, topic 2 is the address of the spender. So that's what we are doing over here and assigning them to variables. And if wallet and spender addresses are found, we will push some other data to the results, which is the token address, which we will get from address, and then wallet will be wallet, which we just extracted over here. Then spender will be the spender, which we extracted over here. The amount of token will come from the data field of the log. As you can see, it's being emitted in the data field. We will apply the hex to decimal function on that, and we will apply the same function to block number as well to get the block number. And then we will get the transaction hash from the transaction hash field. And then we have some error handling saying that if any error occurs, console.log this, and if no data is found, return null. And then finally, we are calling the main function and saving all the data we get from find and filter logs function into a variable called filtered data. And then we are returning the filtered data. So if we run the test, you can see that we are getting the token amount and the block number. After converting hex to big integer, we are getting the spender address and the wallet address after removing the padding, and we are getting the token address from the log address field and the transaction hash from the log hash or log transaction hash field. And then you can see we have multiple logs for a particular block. So QuickNode Stream is very robust and it can handle reorgs as well. So you can do that by restream on reorg, where if a reorg for a particular block happens, that will be streamed again. Or another option is having a latest block delay, where you can set the delay for blocks, let's say 10 or whatever number you want, just like how you see block checks on different exchanges or explorers, to reduce the risk of block reorgs handling on your end. But you can just select this option if you want the reorg to be handled on QuickNode's side. Then click on next and select a destination type. In our case, it will be PostgreSQL, but you can select AWS S3 bucket, you can select a webhook, a Snowflake instance, anything. But for our case, it will be PostgreSQL. And we will get these details from our Tembo dashboard. So hostname will be this, port is 5432, which is correct. Username is Postgres. Port is 5432 because that's usually the default port. And then comes the password. Then the database will be Postgres. And the table is the table name which will be created in your Postgres database. So let's call it token allowances new. Then you can have a retry period, pause stream after how many ever retries you want. Let's say that your Postgres database is unreachable, so the stream will try to retry after, like, let's say if it's sent to 1 after every 1 second, and if it's set to 3 retries, it will stop to retry after 3 retries. You can just set these values as anything, and then we will test the destination. So as you can see, destination test is successful. We will create the string. So as you can see, the current block is this, and the end block is infinity because we did not send the end block. So our stream will keep on sending all the latest blocks as they come. You can check your logs for the stream if any error occurred, or metrics for your string like how much data is sent, etc. And then on the overview page, you can see all the other details. So let's just pause this stream for now because we do not want our database to get completely full. Now let's take a look at our database. So I'm using this Postgres client. You can use anything. So what you need to do is, if you are using this client, is click on new server from URL, go back to your Tempo instance, then click on copy again, go to Postgres, paste the URL, take out these parts and add server. So as you can see, the server is added. Open that. So it will need to connect to the server. All right. So this was our newly created table using the stream. And in that table, we will have the block number, the network, the stream ID for that particular stream. And in the data field, we will have all the information around token allowances logs for that particular block. So as you can see, we have token, we have amount, wallet, spender, block number, and transaction hash. So let's go back to our steps and review our progress. So we have successfully created a stream and filtered the logs and sent to Postgres database. Again, this is just for demo purposes, but if you were to create a production app or a actual app to check the allowances, you will have to index the entire data from the Genesis block until the latest block and keep the stream going so that you can get all the latest approval logs. And now what we will need to do is we will need to create a new table in our Postgres instance and create a Postgres SQL function so that we can get this data from our token allowances new database or table and refine this data, because these contains each and every log for that particular event, right? So what we need to do is we need to get wallet addresses and get their token approvals for particular spenders. Let's go back to our terminal. So let's create the table. And what we are doing over here is creating a new table called wallet approval stats latest. And the table has 4 columns. The first column is wallet address, which is of character dataset. Then we have approval history, which is of JSON binary data set. And then latest approval, again JSON binary data set. Approval history will be an array. And then the last updated column, which will be a timestamp. So let's create the database. All right, so the database should be created. So if you go back to your Postgres or Postgres client, you will be able to see that wallet approval stats latest is created with these following columns. Now, another thing what we need is a SQL function to process the data from token allowance new to wallet approval stats latest. What our function will basically do is it will look for unique wallet addresses and enter them into this column. And then it will look for token and spender pairs and keep on appending to the approval history column, as well as add that to latest approval column as well. and add the timestamp. But if that particular token and spender pair is found again, but for a newer or higher block number, it will update the record in the latest approval column. Now let's take a look at the PostgreSQL function. So this will be a function whose name will be process wallet approval stats latest. And what we are doing over here is we are running a cursor on token allowance new table for all the block numbers in ascending order. And then we are declaring few variables where the row data variable will store all the rows from the token allowances new table. Like this will be a row, this will be another row, this will be another, this will be another, and this will be another row. Then the allowance events variable will store all the data in the data cell specifically, which will be this data. Then the allowance event variable will store particular allowances within this data, which is this. And after that, we will store wallet in V wallet address and approval data like token, spender, amount, block number, transaction hash in approval data variable. We'll store the total number of rows in this variable, the processed rows and skipped rows because we want to handle error as well. And then we are counting total number of rows and printing it over here. And then we have a loop function to go over the row data variable, and we are getting the data from the row data variable and seeing if it is an array, and if it's an array, storing the data of the data column in the allowance events variable, and if not an array, we are making it an array. And after that, we are going over each allowance data and storing it in allowance event from allowance events. And then we are getting the wallet address, and if wallet address is null, we are throwing a error message. And then we are going through each field like token, spender, amount, block number, transaction hash, and adding them to approval data field. And after that, we are actually adding data to our columns for this new table, where we are adding any new wallet address to the wallet address column. And then we are concatenating the token and spender addresses from the approval data variable. And if a wallet address is found again, we are adding that data or appending that data to, but if that particular token and spender pair are found again for a higher block number, then we are updating the latest approvals record and then adding a timestamp for the current update. And then we have few messages over here which will be printed. For example, number of rows processed. If there's an error fetching data from a block, we will print that, and then once the processing is done, we will print this finished message. So let's add this function. Let's copy this. We can close this, go back to our terminal and add this. So as you can see, our function is created. Now what we will need to do is we will need to run this function so that we can process the refined data into the new table. To run that, we will need to run the select command and the function name and a semicolon. So as you can see, we had 5 rows and we have finished processing the 5 rows. So if we go back to our Postgres client, you can see that we had 5 rows. And if we go to wallet approval states latest and then refresh it, you will see that we have the refined data in this table where we have a wallet address, where we have the approval history, we have latest token approvals for each wallet address based on the latest block or the latest block in our index. So now this step is completed. Now the next step will be to build a React app and a server to talk to our Postgres database. So our React app will look something like this, where it will have a app.js file modified like this, where we have a wallet approval search component inside the components directory and a server.js file. Server.js file is basically a Express server using PG client or Postgres client and also using CORS. And we have a .env environment variable for our QuickNode endpoint URL and our server configuration details. So over here, we are creating a pool variable where we will have all of our server configuration details like the username, hostname, database name, password, port. The same thing which we added in our streams configuration. And then we are saying that SSL is not required. And we are adding a test to see if our Express server is able to connect to the server or not by just doing a simple select query. And if it's connected, we will console connected to the database successfully. If some error occurs, we will console the error. And then we are initializing the Express server and saying that our Express server will be using the CORS policy or CORS guidelines. And then our server will serve on this path. And what we are doing is we are querying our database for latest approvals, approval history from wallet approval states database. So I already have another database called wallet approval states, which has a lot of rows already indexed, which it gets from token allowances table, which is created by Stream. So this table I had indexed earlier, which has like 11,550 blocks, which is still not the entire chain, which in production you'll need the entire chain from the Genesis block to the latest block, but it's obviously more than what we just indexed, the 5 blocks. All right, so we will be using this table, which is exactly similar to what we just created, but just has more records. So we will be getting data from wallet approval states table, where it will look for wallet address taken from the user. And the wallet address taken from the user will be wallet address variable. And if the length of the result is more than 0, we will add them to rows variables. If not, we will throw some errors. And then we will be running our server on port. And then what I have basically done is added a server script for our server.js file, so that whenever we run node run server, this file will be initialized. So let's first run the server and then look at the rest of our app's logic. So to run the server, npm run server. Sorry, it was npm run, not node run. So as you can see, our server has started and has successfully connected to the database, which means that our server was able to make a call, a simple select call to our database. Now let's look at the actual logic for our app, which is in the wallet approval search component, which is over here. So we are basically importing a bunch of stuff over here, where we are importing React, the ethers library. We will need ethers library to make call to the smart contract using QuickNode endpoint to get the name, symbol, and decimals for each token. And then we have the Axios library to talk to our server, and then some material UI components for designing. And over here we have React state variables for wallet address, for approval data, for history of approval data, and a modal for our history event, which will be a pop-up for our history of approvals, and then a state variable for error, a state variable for loading. And then we have a handle search function where it will set the loading true. Whenever the search button is clicked, it will set the loading true. It will initialize the set error with empty, then it will have set approval data and set history data to null, and it will make a call to our server running on 3001 port, and then get the latest approvals data and approval history from the response of the server. And then if latest approvals data is found, we will store them in processed approval and then set the approval data, so that whenever we call approval data, we will get the latest approval. And we will do the same for approval history, but we will first check if it's a string or not, and then parse it to JSON, and then store it into set history data, which if we call history data, we will get the history of approvals for a particular wallet address. And if no latest approvals or approval history is found, we are throwing an error over here. And finally, after the data is fetched, we are setting the loading state variable as false. Then we have another function called process approvals, which will process the approvals and get the name, symbol, and decimals for that particular token contract. And we will be using our QuickNode endpoint over here. We have the ABI for those three functions for name, symbol, and decimals. We are getting the token contract address for the approvals data, and then making a call to the contract, getting the name, getting the symbol, decimals, and if any error occurs, we are catching that, and we also have some placeholder values for that. So we are calling these functions over here inside the handle search function for latest approvals and approval history, as you can see over here. And then we are storing the processed data into processed approvals variable and process history variable, which later will be available by history data and approval data variables, because we are using state variables over here. So as you can see, we are returning that data over here in this function, and if an error is caught, we will return these values. All right, so once we have the data, we need to display it. So that's what we are doing over here. We have a H4 heading with the text wallet approval search. Then we have a text field which will take the wallet address from the user, then a button which will act as a search button with label search, and once clicked it will run the handle search function. And we also have a circular progress of size 24 if the data is loading, and if the data is not loading, we will have the circular progress as disappeared. And if the app is not loading, we will print the approval data. So we will create a table with these fields: token name, token symbol, amount, spender, block number, and then we will get the data from the approval data variable, which is our latest approvals, and then store the data accordingly: token name, symbol, normalize amount, which will be normalized for decimals, spender address, block number, and then we will do the same for history as well. But just the thing with history is that it will be a pop-up modal, which you can see over here. And then we also have a close button on the pop-up modal. And then we are exporting the wallet approval search component, which we used in the app.js file, which is our main React file. Now let's run the app. So npm start. So as you can see, this is how our app looks like. We just have to enter a wallet address and click on search. Now is loading is set true, and since the data is loaded, it's set false now. So as you can see, we get the token name, symbol, the amount it's approved for, and the spender contract's wallet address, and the block number in which it was approved. And you can also see the history of approvals. Now let's just grab another wallet address from our database just to make sure that we get a response. So let's search for this wallet address. This wallet address also has one approval. Now let's look at a wallet address which has more than one tokens approved. So okay, this wallet address has two. So let's take a look at this one. All right, so as you can see, we were able to fetch the data. So this is how you can easily create a complex app like this using QuickNode Streams and index any kind of data quickly using streams, or any kind of refined data using streams with filters. So hope you learned something from this video. If you like the video, give it a thumbs up, subscribe to the YouTube channel, and let us know in the comment section what next use case you'd like us to build using streams or filters. So until then, see you.